Hello to viewers, welcome to my channel Science to Technology. In today's show, Computer Fitness Day, we're going to talk about IPKVM and IPMI. So let's dive deep into it. Now these things are a bit heavy, bit technical. So question becomes, why do we need something this technical? Well, reality is most servers are headless. What does that mean? That simply means they're fundamentally supposed to run over the internet. They're almost like a big ass router. They're not supposed to have their keyboard, mouse and display and all that jazz. They're not supposed to. So they're headless. Now here's the many times you could have a server rack. I'm talking about the physical hardware. You can have a server rack and that could have 20, 40 physical electronically independent computers that are acting as a server. But here's the deal. How many keyboard and mouse you need if you have to connect all of them? You don't, because it will be bonkers, stupid. So we generally utilize this sort of device where you just have one keyboard, one mouse. And you see the point? We need some way of handling multiple equipments on limited numbers of I/O, input and output devices. And that's just on the server head. But here's the many times people who are developers or working with some heavy load, they may themselves have a multiple system, multiple boxes as they call it. For example, I'm a single box user, so I have one computer, that's it. But many people have one box, one rendering farm. Artists, many of them have that. Many times they have a compiler box where it's just like it's a heavy crunching device. They just send data, it crunches it. You could even have network attached storage, things of this nature. So you could literally like a actual genuine requirement where you are just one person but still have multiple computers. But again, how many keyboard and mouse you gonna have? You can't have okay, I have 3 computers, so 3 keyboards and 3 mouse. Yeah, that's not viable. So we still require a scenario to have the limited IO going to all limited IO to unlimited devices, so to say. So we need IO for all of them, because again, there is no point controlling keyboard and mouse if you do not have control over the video output. So we need that. Tech support. Many times nowadays, this is becoming a common theme where let's say you have an issue with Dell computer, they will say, hey, we'll log into your system remotely. Now you would think this will work with servers. Yes and no. Yes, it does work. Like that's the level 1, basic level testing and diagnostic. But that assumes almost majority of your computer is intact. Like software-wise, software stack is fully working. The OS is almost fully working. You may have a wrong setting. In those sort of scenario, these things can be awesome tool. But here's it. What if something bit more heavy happened? Let's say it got stuck in a boot loop. Then what? You can't log into it because again, it's stuck in a boot layer. Basically, it has reached to a point where your software, again, you need kernel to work. You need operating system to work. Then you need program to work. Then you can log in. But what if the base level, as in the boot level, is failed? Then what? So it creates a scenario where this idea of like remote login, that the idea is awesome, that you can have server all around the planet, and you can have a dedicated team in one centralized location managing all of them. But what if they shut down? What if they restart? What if they get stuck in boot loop? We did have this situation. So you realize that the moment system malfunctions, this whole remote system, they no longer work. So how do you manage something that is frozen? Because here's the servers have slowly grown from 1980s to what they are now. There was a time where the idea was like, okay, we're gonna have a building, and then like ground floor was the server, and people just used to actually go and maintain it. But as a server became more big, more humongous, more heavy energy draining equipments and heavy water loads, yes, server consumes boatload of water for cooling purposes. The idea was shifted, like we're gonna make a dedicated building. Now here's the problem. You need someone who's working in your office to go pick up a car and go to that physical location and do this. So that creates a problem where it's like, eesh, that's expensive. You can do it, you solve it, but expensive, undesirable, so to say. So there are certain scenarios where IPKVM and IPMI would help a lot. And be mindful, this system shutdown that did happen, it could have been saved. And again, many people did recover because they had IPKVM or IPMI. Those who did not, they got stuck because again, this airport company that's suffering from this issue, they could have easily fixed it. I can guarantee you, the moment their tech support figured out what's the problem, they were like, bro, I got this. So why didn't they got this? It's just like, I have to physically go into every computer. You see the problem? So this is the problem. It does happen. It's real. It's not like, oh, Linux never crashes. No, it's real. We've been here, done that, got this. It happens. All the things crash down. You have to design for it. So what is KVM? KVM is keyboard, video, mouse. KVM. So that's there. So the idea is, the moment we started to make computers, we realized very early on that you will have a requirement of a switching box that takes limited number of inputs and outputs and connects it into larger array of systems, so to say. So you just need a way to map the system. It's like this keyboard talk to this mouse talk to this display take the output from this, and then you change a switch here, and it's like, okay, now reach from this, now study this, then switch again, now this to this to this. So we realized very early on that this is a requirement and we need to have it, and people started to work over it. Now here's the, this is awesome. This is how you find server racks in, like, 90s, where you're like, okay, you have server rack, it has, let's say, 20 computer, and you have a roll out display and keyboard. You just pull it out, open it, and it's like, now here's the deal. How do you select which computer? All the computers are pre-wired, meaning the VGA ports are wired, the keyboard mouse are already wired, and then you have the switch device, which is KVM, and the KVM is like, I got you. Which computer you want? Number 4, I got you. Number 4, working online. Number 2, number 5. Like, you can have limited number of input and output, and you can handle all the computers. So this is how we started. Now here's the, somebody figured out that if you have this device and you have input and output, what if this distance could be infinity? Now again, not infinity, but you get the point. What if you have internet protocol packaging system here? Basically, you have internet bridge here. Now that physical distance is no longer required. You can have a server, and that's it. Server could be anywhere. Generally, you should not exceed the continent, because if you have to do way too many hops, the latency will become bad. So your mouse will be like, yo, and the computer will be like, relax, man. Take a chill pill. So for that reason, you do want to be on the same continent, even though you can be somewhere else. It's just not recommended. Like, typing becomes slow at that point in time. So, but it did solve a problem where you no longer need to physically on there. You have physical access to all the hardware without being physically there. So this was a super amazing development of KVM. KVM got a package manager in between, basically KVM, input and output, IP manager right here. That is IP KVM. And be mindful, the KVM ecosystem is made for admin work. They're not designed for gaming. They're not designed for dev work or creative work, things of that nature. So they are horrendous in quality, meaning right now, my desktop computers are like full HD, 120 Hertz. This puppy, 4K, 120 Hertz. These puppy, KVMs, yeah, you would be lucky to get full HD 60. Like, only recently they reached there, only recently. And that's why, like, majority of the server still has VGA output. So it's literally stuck in 90s. It's like, hey, it works good enough, because the logic there is that it's an admin system, meaning you're only doing command line and all that jazz. You do not need resolution and all that. While you do need, it does make your life easier, but the KVM hardware is kind of stuck. And because it's not a common public device, it's not mass produced enough. So it's like, it's a very niche item, very expensive, very outdated, basically worst of all. So it has reached a point where you have to pay bonkersly large amount of money to have a KVM. Now you would understand, hey, you have keyboard and mouse, so why can't you just have a data port? Yeah, most of them, if you're lucky, have data port of mass storage, USB 2.0, and you're like, okay, how the heck USB keyboard mouse is working if you require a different protocol? Well, USB keyboard and mouse utilize what we call HID, H-I-D, human interface device. So the protocol is designed in such a way to handle this sort of situation. However, when you're talking about mass storage, like, nobody bothered to do it. Like, literally nobody bothered to do it. So now again, there are some, but it's expensive, idiotically expensive to have USB 2.0. So to give you a context, there is one gentleman, amazing intellectual gentleman, Wendell from Level 1 Techs. He literally opened a company and started to make KVMs for pro use. Meaning, this puppy is the only puppy you can buy in the market that actually support display port output at full resolution of like 4K to 8K. Do you need that? Like, there's a genuine point. Do you need that? Here's the deal. This is one of the best example they have, which is awesome. It's like, medical displays that are used for MRIs, those are high-end displays. Those are expensive AF. Now, here's the many times you have multiple boxes, like CAT scan or whatever have, like, for some reason they have multiple boxes and they have to buy multiple displays. These are ludicrously expensive. So this device, they put it there because, again, it's designed and tested for today's technology, not like 1990s. It can actually handle all the requirement, the bit depth and all that. Basically, it truly supports a display 1.4 standard. So it's like, I got you, fam. So high grade, 2 monitors, and you're handling multiple machines. You good. So that's a medical grade use case, because that, like, KVM have never upgraded. So he literally made his own company and fixed it. And again, also added USB high speed, aka USB 3.0, aka they started smoking weed. They renamed this puppy 3 times. So basically we simplify and say 5 gigabits per second or 500 megabytes per second. So at that point, you can even do BIOS updates, and not BIOS, like ISO updates. You can basically install Windows and all that. It will be very quick. So he is the only one that is popular enough and actually makes high-end one, and he's actually trying to make where you can have like dual display in and dual display out. That's very rare. And he also has one where you have quad display in and quad display out. I do not even want to know what kind of stock market. That's the only place where I can see people actually have use of 4 displays, where you're like, okay, I have 2 machines and I need 4 output with all of them, and I need 4 monitors. It's like, I got you, fam. He has some upgraded one which has 10 Gbps of USB chips, which is like beyond rare. It's like beyond rare. So KVM is like awesome tool. People upgraded, but they got stuck. Level 1 Techs is one of those things that actually try to solve it, but because again, it's a small company, it's not like Asus or something giant, price is high. But again, if you need it, again, for medical people, they're like, shut up, take money. For other people, it's like, yeesh, that's expensive. But again, for what it does, it's awesome. So this is KVM. So KVM, you have to add a separate bridge device. But what if the bridge device was in the computer? So IPMI, or Intelligent Platform Management Interface. So all the things, what do we do with KVM? At the end, somehow figure out a way to package it into Internet protocol. But what if the output is the Internet protocol, meaning a Ethernet cable is the output, meaning this chip studies everything. Gets the display output, awesome. Takes the keyboard input, takes the mouse input, takes the video output, takes all the sensor data, and directly converts it into internet packet directly, like you just have an Ethernet connection. So this is how we created IPMI, and these are only found in pro grade and server grade hardware. Like the easiest way to find the price of a motherboard, see does it have like IPMI port or not. If it has, it would be ludicrously expensive, even old ones. Because here's the deal, the motherboard, normal motherboard is like motherboard. This motherboard is motherboard with a tiny motherboard on side, or SoC. These things are a full-fledged computer which is monitoring everything, because again, it's integrated. They actually expect higher performance out of it. Higher performance as in like in terms of depth. So not only it can see the is it on or off, things of that nature. It's supposed to also, many of them have a crash dump, meaning system crashes, it creates a registry file, so to say. They're supposed to safeguard it, meaning if the system gets corrupted, no problem, I'm keeping the safeguard of it. Another thing is it can monitor the fan, it can monitor the power consumption. It can basically, it is a very low level control of the system. And yes, it can, if let's say OS gets frozen, it's like, bro, I got you, restart. It's like, whoa, the OS got corrupted, no problem, I got you, fam. You can literally from outside install a completely new operating system, because it's a SoC, almost like how a smartphone is there. And it's a pro-grade equipment. Let that be very clear. This is expensive because not like, it's expensive for 2 reasons. You actually have to make a different motherboard. Not let's say ASUS is like normal motherboard, go. So price is X. They're like server motherboard, go. It's like price is 5X. It's like, what the hell happened? That is not mass produced. So that is expensive. Mass produced as in like millions of Ryzen compared to that. So it's not Snapdragon, okay? Let that be okay. It's not Snapdragon, like millions of being made. So it is expensive. And then they have to redesign the motherboard so it has like low-level accessories, like how much CPU is consuming, how much RAM is running and all that. Like, so it needs a really good detail, where it's like, I have to keep an eye on the, pulse, so to say. So it's expensive. It's independent. It must be so thoroughly independent that it does not give a damn what happens to OS. OS got corrupted. It's like, I don't give a damn. Rootkit attacked. I don't give a damn. This happened. I don't give a damn. Basically, that puppy is, I do not give a damn. So it has an independent core operating system of the core operating system. So operating system can go YOLO. This like, I got you, I'm going to flush you again. And it has control level boot, meaning is the daddy. Simplified, that's the daddy. Keyboard, mouse, data input and output plus video output. And all of that goes to that chip, and that chip sends out direct internet protocol, meaning Ethernet. It can directly give you the Ethernet output. Now, integrated nature of it does increase the cost, but does allow very deep level diagnostics. For some people, it's like day and night. Like it can actually figure out, hey, the fan is the one that's broken. That's the reason why it's causing system to shut down and all that. Now, like, why would a server shut down? Wouldn't you have running systems and all that? Turns out many times people, to get extra performance, they might not want to. They might not, they literally might not have a fan curve adjuster there. They just like, okay, it's a fan, go YOLO. So again, they may not have a feedback loop for be mindful. You would be shocked how many times this sort of silly things have destroyed things. So that's why, like, this is from Asus. Asus is like, what if you have a gaming computer that is like so high end, and for some reason, again, I could see in gaming studio, if they need a box for rendering and all that, or compiling video games, they're like, okay, IPMI expansion card. So all the fan goes into this. So if your system glitches out, there is a very tiny probability that it could glitch out with PWM signal being stuck to off. So yeah, that would be very bad scenario. So it could happen where it's like a software glitch fried your system. This is like, I got you. I will not allow that to happen. So this system will directly override everything and you only get Ethernet out. So basically it's a KVM with some extra depth system with IP system. Integrated nature, and again, this is like a pro grade audio equipments, and it's like IPMI port, not Ethernet. I mean, like, you're not supposed to directly connect it to the main Ethernet because there is some serious risk to this. Now we come to the dangerous part of it, risk and cost. You did realize this chip literally can control your whole system. So now, whenever you're talking about the servers, you generally talk, oh, I'm going to have firewall, I'm going to have this modem, and I'm going to have this AI-based packet inspector and all that. You have all that stuff. But what happens somebody controls this? Yeah, you did. So reality is generally many times they may not be connected. They may have a scenario where it's like, okay, all the, let's say, this physical building has a server rack of, let's say, X brand. So X brand is like, bro, I got this like 100 computers. They have all IPMI connected, but it's not physically connected to the network. Something bad happens, then they will pick up a phone and tell the guy there, it's like, please connect IPMI of this, let's say, rack. Then they're going to connect, only then they're going to, they never expose this unnecessarily because you have to follow a completely secure protocol. You cannot oops this. If this gets oops, yeah, that's bad. Like if you think DDoS is bad, if this gets attacked, this is worse. This is so worse because it can do one of the worst thing where it's like, it can install things in the background without you ever detecting that you have been compromised. Like it's dangerous. It's what we classify as bare metal access. If you have access to this chip, yeah. So that's a very serious, and be mindful, the same applies on IP KVM switches also. So IPMI or IP KVM, it's inherently exposing the hardware to the ports. So if compromisation happens on this pipeline, yeah, you're dead. So fundamentally that, because of the fact that you require a custom motherboard and different modification and regular security updates, and some of the securities are so high priority that if you do not update them, the company will literally brick your board. They're like, hey, because again, if let's say Dell gets hacked because you did not update the IPMI, people will blame Dell. They will not blame you for not updating. Like same happened like how everybody is blaming Microsoft rather than Cloudflare. It's like early few days everybody was just making memes of Microsoft. I'm like, this is the first time Microsoft is not at fault. But you get the point. So you have to pay license fees and they are expensive. Let me be very clear. They are expensive. They are so expensive that even Apple will have a hard time paying it. They are expensive. So, and again, it has to be because again, not only the motherboards are rare, it's not mass produced, so it's almost custom built. Each system is custom built. Again, in a server context, I get it. And again, security update, they have to keep supporting it, and it's very expensive. And there is very low competition and very specifically alternates. What else you gonna do? You can't run a server. Oh, I have this awesome server that is working awesomely. It's just that something bad happens, then I'm like stuck. Yeah, you need this. So because of the need requirement and the lack of alternatives, people are stuck. So you have to pay for it, and be mindful. This is so painful for many companies. They're like, I will only pay for 1 or 2 licenses. And yes, there is bargaining with licensing. That's how expensive it is. So this whole ecosystem, IPM, I2, and they also keep getting upgraded. Version 1, version 2, version 3. Sometimes they have a daughter board. Rather than being soldered on the motherboard, they may have a daughter board where you can swap the daughter board so it keeps getting upgraded. I think newer ones have that. Cannot guarantee it. I've only seen it in a few systems, but that is also a trend. So there is very significant risk with this. You cannot just like, I'm going to connect it. It's like, you just exposed the one thing that should never, ever, ever be exposed. So that's there. And to make sure that never, ever, ever stays never, ever, ever, you have to pay a boatload of money. So thankfully, open source happened. Now, Raspberry Pi is a very big achievement of humanity. Whereas like some people got together, it's like, let's make a computing device, let's help children get into computer. Did it ever pay off? That's the question, right? It's like, okay, we had this as a, you must have heard people, oh, people use it in industrial scenarios. Like, okay, what else? This is the what else. Because of the fact now you have a computer that is low cost in comparison, that has enough ecosystem where it's like everybody is working on the kernel, everybody is trying to patch it up, and hardware is keep getting refreshed. So that created a healthy ecosystem where somebody is like, what if rather than having custom SoCs, what if we utilize this Raspberry Pi itself? We just made a daughter board for it. So BliKVM was made, and be mindful, this is just one popular example. Other people have tried it, and this company was like, what if we make this and just sell it as a product, where we have Raspberry Pi Association working their ass off, whole community working their ass off, we working little bit of our ass off, and then we work our ass off on hardware, and then voila, you have a package deal. You buy this puppy, done. Now you can use a normal workstation as a server grade system because you have full grade access. Not as deep as IPMI, but more than good enough. And be mindful, because of development of the fact that Raspberry Pi is perfect for this because it has GPIO pins. That's very clear. It has GPIO pins, meaning you need to sometimes press a button, right? That requires a physical bridging of contacts. How would you do that? The silicon has the chip inside it. So what if you take the GPIO pins, split them inside the computer? So the idea is you put this inside your computer box. This goes into ATX power control circuit, meaning on off. LED, you can get the status out of it. So power LED, hard drive LEDs, restart button, power button, all that jazz. You can get the data out of it. Because again, general purpose input output pin, they can be configured in such a way that they are output, as in like they will turn on, do like this for your reset switch, or for hard reset, 5 seconds. You have to do it for 5 seconds for hard reset for PSU. So that all that is possible with this because it has GPIO. Because of the software and hardware being polished and worked on with a giant company and everybody is working their ass off, that's actually safe and stable environment. So they got the hardware, they got the ecosystem to support it, they just made daughter board around it. And of course, the software to make everything easy and manageable. And voila, this actually became a thing. Like BliKVM is on version 4. There is other Magic Box also. And then this company, this whole idea is like, what is it? It's actually ARM SoC running Linux kernel, running a software. It's like, what if you yeeted Raspberry Pi, which is super expensive nowadays, you replace this with Alibaba's special chip. You did that. That's a BliKVM, same thing. It's literally the same thing. They're just like, hey, we do not actually need the horsepower here. The horsepower here is like, let's say 100 horsepower. You only need 50. So they're like, what if we buy 50? So this will cost you 30,000 rupees. This will cost you 15,000. More than good enough. People are like, dude, this can actually do 4K 30, which mind you, IPM can barely do full HD. It's like, shut up, take money. For many people, shut up, take money. And this allows all the old systems, all the system where you do not want to pay for the license of IPM. They're like, bro, I got this. I got this. And this is a new device that is being under construction right now. This is nano KVM. It's like literally that size. And at this size, people are saying, why buy this and then buy a KVM to switch multiple devices? What if you buy, and yes, this is cheap enough where it is in theory possible, where you can buy like a bulk order, have enough discount on each, where it's like every server gets one. So at that point, you literally have IPMI on each device. You no longer need a extra KVM. That's possible. So this is a very good development. And again, it directly allows businesses to save money rather than just like, it's expensive thing. And again, this also helps the home developer, meaning if you want to make a NAS, NAS is only as good as its management system. If its management has the industrial grade management where it's like, hey, OS had this issue, let me stop it before it scrambles the hard drive, you can do that. So for many people, the fact that you can save money on hardware, and be mindful, while I'm talking the cost, many companies also created a system where it's like, hey, we're gonna charge you something for the software support. Now, like, I want, would people pay for it? Here's the deal. People who are paying for IPMI license, they are like, shut up, take money. That's how much difference is there. And be mindful, this is transparent to you. Meaning, if you are a competent software company, competently dealing with ARM system is your specialty, you'll be like, bro, we got this. We are working with you. Like we did that with Linux. That's why Linux kernel is so stable. So many people are like, bro, we are paying you. We are working with you. We got you, fam. Both of them working with each other, software getting better, everybody wins. That's a real thing. So it's really like something significant. That's like, whoa. Like back in the background, nobody gives a damn, but this change happened where it's like Dell, HP and all that, like either you sell us a kidney or you do not get a IPMI. They're like, oh, you actually have an option now. Oh, wait a minute. You actually have a software option that is getting refreshed and rebooted, and it's open source enough where every Tom, Dick and Harry is working their ass off to make sure that it's penetration tested. Yeah. Like, again, let that be figured. Nothing can ever be made that's like absolute security. It's just you can make it like, oops, security failure should not happen. You should not be like, that's the only thing you can truly ask. It's like a sword and shield kind of argument. It's like, can a sword ever be awesome? Yeah, for one generation. Then the shield will become Gen 2. Then it's like, okay, the Gen 3 has to be the sword. Then it's like, brick, tick, tack, tick, tack. So all these things have to be do is good enough where it will like, nobody should be like, oops, I destroyed your server. That should not happen. And enough user, supply chain, all of this. This is a magnificent thing. That the fact is there is metal grade hardware, like metal, actual metal. It's not like plastic. Yeah, they have resin printing because it's so small. But you get the point, like it's a whole ecosystem now. And again, software is supported, hardware is supported, you have options you can make yourself. This is magnificent. This is what we want in computers, where computers are, rather than being controlled by like the big giants, it's like, hey, we got some control of it. So this is very good, healthy development that happened, and I'm very happy. And again, for many of you who want to go into computers and want to learn it, it may be a very good investment for you to like study it, because again, this is exactly what you do. Of course, a bit more in-depth, a bit more complicated and outdated version of Java for IPMI, but you get the point. This is a very good development. So this was my presentation on what is KVM and IPKVM and IPMI. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.